maximum or a minimum. So I know that at 0 on this one I have a 0. At, I don't know, -1.5, no, -1. I have a 0, 0, and 1. Agree?
Wait, why is that 1 and not 1?
The 0.
Oh, okay.
The 0 of the tangent line. Yeah, and that's fine. You don't have, they don't remember, right? The next one I would say none. No zeros. Agree? The last one, this is going to be the toughest one as far as 4.2 or something. And 2, maybe 2. And 4.2 again. Something like that. Okay, so far so good, everyone, with but that's something we can pick out. Even if we're really bad at this, we can pick that out.
Yeah, shouldn't there also be one?
Oh, yep, thank you. I missed that one. Okay, so let's go back and now kind of figure out what the derivative looks like. What's the slope here? It's really, really low positive number. Really, really close to 0, but a positive number. Does everyone agree? And then it is increasing, right? Everyone agree? Slope is 0, a little more than 0, a little more than that, a little more than that, a little more than that. And then close to 0, I start to decrease again. So I go up and then back down. And wherever that concavity changes is where that happens. So looks like it also has a horizontal asymptote at 0. After 0, my slope is a small negative, but then it gets to be a steeper negative and then back to a small negative. It's kind of the same look except down there. And again, that point would happen when the concavity changes, whenever that may be. Now, of course, you notice I didn't even put any numbers on that. I don't know how steep the slope gets, but I do kind of know a general shape of what the graph would look like. Okay, let's look at the next one. Slope. Negative, really steep negative, right? Really big negative number. The farther out I go, the bigger negative number it is. So this is kind of coming like this. Since negative 1 is a minimum, I do cross the x-axis. Would you agree? Cross there. And then my slope is positive for a little bit, but then it goes back towards 0. So again, I don't know how high this goes up, but then it turns back around. I have a maximum at 0, so I cross the x-axis again. And I have a minimum at 1, so I cross the x-axis again. Does that make sense? A quartic being a cubic. Okay, this slope starts out at almost 0. Not quite 0, but almost 0. And then increases, kind of looks the same. Why would that be with something you know? What is that the graph of? E to the x. What's the derivative of e to the x? E to the x. That's why. Okay, this one's the toughest one. As I go farther out, it appears that my slope is a steep negative. Crosses. I don't know how high that goes up, but I do know that somewhere in here, right about at 3, I'm going to have a maximum and turn around and go back down. At 0, I'm going to have a change in concavity, so I'll turn around. Something like that. Is it perfect? Probably not, but I can get a general shape of what this graph looks like. Any questions about that? So today we're going to be looking at, this is an online derivative plotter if you ever want to just Google one. But today we're going to be looking at the connections between the function and the derivative. So I have a function up here. You see how it's doing the slope of the tangent line right here? See that? It's plotting the derivative using that slope. So that's what we just did. We looked at the slope of the tangent line. And plotted a derivative based on that slope. Interesting little thing to play around with. Today we're going to be looking at the connections between F prime, and F double prime. I'm going to give you a handout of notes so that you don't have to write it much. On the last. Oh, you're right. Thank you. I gotta go back to the last example. I think I said it right, but I did it wrong. What is it doing right here? Increasing. So where should it be? Sorry about that. Thank you. Yeah, it's exactly the same except the other way. I think I said everything right, I just drew it backwards. Everyone agree? Thank you, Joseph. This is just a little reference sheet. You can't use it on anything, but it just gives you the connections between F prime and F double prime. Something I noticed in my AP Calculus class is that they tried to use this as their, oh, actually, I didn't use this first. I forgot about this thing on the back. My AP Calculus class tried to use this in their justifications. You do have to go back to definitions to do justifications, but it's still a good, really good reference. You need one more. I just finished grading my first full AP Calculus exam.
What was that?
All but 2 of them passed, the very first one.
Like
a 3, 4, or 5.
How many of them made a 5?
3 or 4 of them. And I use the hardest AP grading scale. Like they're, every year the scale changes. I use the hardest one. I didn't use the lowest year. If I had used an easier year, I would have had more 5s. It doesn't really change the 3s as much. The 3s kind of stay the same. Yeah. The 2 that wouldn't have stayed, I don't think. But just because they didn't doesn't mean they won't. Right? This is our first practice exam. And that's AP Calculus everybody, not AP Calculus best and brightest 30 in the class. Okay, given the graph of F prime provided below, answer the following questions. Where does F of X that the graph of? It's the graph of f prime of x. Why do I need to know that? Drastically changes my answers, doesn't it?
Yeah.
Anytime you see a question with a graph involved, please ask yourself the question, what is this the graph of? Always ask yourself, what is this the graph of? This is f prime. What can f prime tell us? When the original function is increasing, decreasing, when it has maxes and mins, all of that information. What do I look to this to figure that out? Where am I looking to figure that out? What does this tell me? What are zeros on the derivative? Critical points, right? So those are the places where I may have maxes and mins. Since I am crossing the x-axis, I will have maxes and mins at those points. If I were you, when I see a derivative graph, some of you can just see it in your head and you're done. But if you are having a hard time seeing it, draw a quick sign chart. So I'm going to put that number and that number on my sign chart. We can figure out what those are. 1, 2, 3 and a half. We'd have to use a little bit of liberties there, but this function, the derivative, is positive because it's above the x-axis. Then it's negative because it's below the x-axis. And then it's positive because it's above the x-axis. How many of you this really helps you figure out number A, or part A? Like doing this goes, okay, that's what I know from the derivative. So if you need to draw that graph, draw the sign chart, do that. Where does f of x have a relative maximum justify your answer? This is one of the second time we've seen this word, maybe. So you're going to get to see how to justify your answer. Again, that word is the one that should scare us a little. Not something we can't do, but let us know this is a hard word. Justify is just equally as hard as the word prove. We've got to make sure we got our I's and cross our T's. Make everything look good. So, first of all, where is the relative maximum, and how do you know? At x approximately -3.5, I have a relative maximum. This for an AP exam question, that's probably a point. I probably got a point from that. Now I need to justify, which is probably another 1 or 2 points. Remember, we've got 9 in each AP problem, so we need to try to get to pass that exam. We don't need all 9, we need like half of them. But okay, so how am I going to justify that? How do you know it's a maximum? Slope of what? See, we got to be really careful. If you just say the slope changes from positive to negative, they're going to say slope is positive, right? So I need to say, what function changes from positive to negative? What's the thing that lets me know that? F prime. That's really the only thing I know anything about, right? So I better use that in my justification because I don't know anything about f of x. I don't know anything about f double prime. So the first thing I'm going to say is the first thing I looked at. First derivative at -3.5 equals 0. Now, is that enough to say it's a maximum? Do I still need to say it? Yeah, that's how I first figured out that it's a critical point. And f prime so f prime of -3.5 is 0, and f prime changes from positive to negative at x equals -3.5. They will take it without saying anything other than that. That's enough. Therefore, there is a relative maximum at negative 3.5. You could also say, therefore, by the first derivative test. They don't make you state the first derivative test. There are some theorems they make you state. That's not one of them. But you could here. So we would say, therefore, there is a relative max at negative 3. Notice I was very clear with my labeling. I was very clear with what function I'm talking about. Those are things that will dock you on AP justifications. You will get very, very good at them. Don't worry, I will talk about them all year long. But that's kind of one of our first looks at a justification. They will not grade a sign chart for justification. Sign chart, pretend they don't even look at it. That's just for you. The justification has to say in words how you know that that's a relative maximum. Where does f of x have a relative minimum justified? We're going to copy paste almost, right? Has a relative minimum at 3.5. Again, that's probably worth a point. It's a 4-part, I don't know, it's probably 2 points each, a point and a point for justification, point for justification. F prime of 3.5 equals 0, and F prime changes. You tell me. Good. From negative to positive at 3.5. Therefore, there is a relative min. So that's what an AP justification looks like. You don't have to write a paragraph. In fact, you don't want to necessarily write too much, but you have to justify. It has to be clear. Big things, make sure you label things appropriately. Star this in your notes. Never turn in anything to me that says it. That word does not exist in this classroom. It doesn't do anything. I don't know what it is. You cannot use pronouns without an antecedent, even in a math class. So you can't do it. So just don't use the word it. Just say whatever it is that you're going to say. Use the name. Do what?
She was like, what if I call her?
Nope. No pronouns. We don't like pronouns. Unless you use an antecedent and define that pronoun. But it's the graph of what? There you go. That's what you gotta say. It's tricky. Gotta have a lot of information. Where does f of x have a point of inflection justify your answer? Okay, now I've got to think, where am I and what am I looking for? I'm looking for a point of inflection. When do point of inflections happen? So answer that question in your head first. What's the definition of a point of inflection? Okay. Second derivative changes signs or the concavity changes, right? Second derivative of f changes signs or f of x changes concavity, right? Well, which one of those do I want to use for my justification? I want to talk about the second derivative or the first or the original. I don't know anything about the original, right? I don't see a picture. Why am I going to be able to use the second derivative in this picture? What is the second derivative? It's the slope of f prime, right? So I can use the second derivative by talking about the slope of f prime. In my justification, I want to talk about this picture I have because that's all I've got. I can't justify by something on f because I don't see f. And you can't say the concavity on f changes. They're going to say, how do you know? I don't see f. So we got to use the picture we're given. We're given f prime. So I'm looking for the slope of f prime to do what? Equals 0 and change signs. Right? Remember that question on the homework that, is this guaranteed to be a point of inflection? Second derivative equals 0, and we said no because we have to know that. So I'm looking for the slope to change signs. So if I look, I have a negative slope, and then I have a positive slope, and then I have a negative slope, and then I have a positive slope, right? So when does my concavity change?
Can you just estimate on that?
Yeah, it's going to have to be, and you saw I did that even on the maximum at approximately 6.5. So we have points of inflection at x is approximately -2.5, maybe? Maybe not. Close enough. Again, we probably picked up a point for answering the question correctly. Now you need to justify why are those points of inflection. So you tell me why are those points of inflection. And there's not only one correct answer. Okay, good. Because f double prime, and I'm even going to tell the AP reader that I know that's the slope of f prime. Because double prime, which is the slope of f prime, changes. Well, before I say changes, equals 0 at those points. And the slope, you can either say the slope of f prime or you can say f double prime. I've already defined that I know those two things are the exact same thing. So you can use either wording there. Does that make sense? When I wrote this down, I let the AP reader know I knew what I was doing. Right? Oh, that's a comma from the top. Sorry about that. We'll fix it so it doesn't appear to be that. 0. We can have one comma and one prime and make this. So the slope of f prime equals 0 at those points, and I'm just going to say f double prime at this point. Changes from positive to negative or vice versa. You can be very thorough and say the slope changes from negative to positive at x equals negative 2.5 and 2.5, and it changes from positive to negative at x equals 0. And that's a very thorough answer, which would be wonderful, or you can kind of do something more like this. You can imagine there are a million different ways to say what I just said, but the big important things are I never used it, and I used the picture that I was given for my justification. You can't justify with something you don't know. Don't try to justify with something that's not given. Other than that, there are a lot of different ways you can word that. Any questions about that one? Okay. Suppose f of 0 equals -2. Sketch one possible graph for f of x. So it tells me that f of 0 equals -2. Why do you think it had to tell me that? A derivative is a slope of a function, right? Would you agree that x squared and x squared plus 2 and x squared plus 10, they all have the same slope, they're just parabola moved around? So wouldn't I need to know where it starts to know which one it was? That's why they're telling me that information. Now they're giving me what's called an initial value. Okay, so after I have my sign chart there, would you agree that the between negative 3.5 and 3.5, my function is decreasing. And from 3.5 to the right and to the left of negative 3.5, I'm increasing. Farther than, no, I'm right, yeah. Okay, and then I have a point of inflection at negative 2.5, 0, and 2.5. So what I'm going to do really quick, this is only for me, is I'm going to put these two things side by side. So I have my negative 3.5 and 3.5. I am positive, negative, positive, increasing, decreasing, then increasing. And then at negative 2.5, and 2.5 and 0, I have changes in concavity. My slope of f prime is negative, then positive, then negative, then positive. So I'm concave down, concave up, concave down, concave up. This piece is not necessary. It's just helpful in knowing what I'm about to try to draw. So at 0, where that point is, I do have a change in concavity. On the left, I'm decreasing in concave up, and on the right, I'm decreasing in concave down. We're going to see how that would work. At 2.5 and negative 2.5, I have another change in concavity. I'm still decreasing, but now I'm changing to concave up. And I do have a minimum at 3.5. And then I have a maximum at negative 3.5. So you can kind of see those changes in concavity. Any questions so far? And then this increases after that. And this decreases. Again, we're not looking for perfection on a sketch like this, just that you get the concavity and the maximum and min correct. Any questions about this problem? It was a really good problem to start our first exploration of justification. Again, don't feel like this is the last time you'll hear me talk about that. We'll talk about justification a lot. Okay. Example number 3. Given that the graph of what? Okay, I need to know that, right? That's the first thing I'm going to pick out on a graph problem. Second derivative of g is below. Answer the following questions. Where does g have a point of inflection? Justify. Well, on the second derivative, where am I looking for points of inflection? For the zeros. See this? This summarizes all the stuff we're talking about. Okay, so zeros of the second derivative. So I'm looking here and here. So I'm going to mental note that. G double prime of it, because I've got to justify, so I might as well start as I'm thinking, write down what I'm thinking. Equals 0 at negative 1 and 3. Now, did I call those points of inflection yet? Is there a reason I didn't call them points of inflection yet? Yes. Which one's a point of inflection? Why? So I gave my options. I said, okay, g double prime equals 0 at x equals negative 1 and 3. And then I said, but x equals negative 1 is POI because the second derivative changes signs at x equals negative 1. And you could go ahead and let the reader know that you know x equals 3 is not a POI, but by leaving it off, we're letting them know we know that. justifications in this short conversation. We're not looking for an expository writing of 10 pages, right? Just a concise, clear justification of why, with labeling correct. Make sure you don't ever use pronouns, things like that. On what intervals is g of x concave up? -1 to infinity. They also would accept -1 to 3, 3 to infinity. They would accept either one. -1 to infinity is great. I've gotten the point for the answer. Now I need to justify. Why? Again, I know this is silly because I said it already, but you need to hear it. I was very clear on what is concave up, right? I didn't say it's concave up. G of x is concave up here because G double prime is greater than 0 on the other. Questions about that? So almost more than anything today, you're kind of learning how to write a justification. And then seeing some examples. I think this might have 2 more slides. Okay, and these are 2 AP multiple choice problems. Try this one. I've got about 5 minutes left. While you're trying this one, I'll pass out your homework. You forgot to ask that yesterday. Oh no, the 4 problems. The homework. I thought you were just doing your normal. You're great. If that ever happens, Claire, just go online and pull the PDF. It's not as much as it looks like. You can tell. Like 1, 2, 3, 6 are mapping problems. Yeah, it's 2 minutes. It appears a lot bigger than it is. Glance at it, you'll realize it's not. I think they're almost all multiple choice or matching. There's 14 problems. Yeah. They take up a lot of space because they got graphs. Okay, these graphs are labeled 1, 2, and 3 are shown above. One of the graphs is F, one is F prime, and one is F double prime, which the following correctly identifies the 3 graphs. So this is a real AP question. What are you thinking? What are you? Yes, I don't know. How are you getting there? What are you thinking about? The zeros and what those might mean, right? So if I pull the quadratic, for example, and look at the zeros of it, those zeros should be what for one of the others, if it's a derivative. If it's a derivative of one of the others, then those zeros should be maxes and mins. Okay. So is there a graph where the zeros on the parabola are maxes and mins of the other? Of graph 2, right? So graph 2, graph 1 is the derivative of graph 2. Everyone agree? And I still don't know where graph 3 belongs, so I've got to figure that out. Do you know where graph 3 belongs? What do you think? So you think that 2 is the derivative of 3?
But 1 is the derivative. Because 3 is completely positive. 1 is completely positive.
Okay, so say that again. You're right, but you're making the wrong conclusion. So she says that 3 is always positive, right? And so that because 3 is always positive, what did you say? But 2 always. So if that were the case, if you were going to make that connection, you would be talking second derivative, right? Okay, so you're thinking that maybe 1 is the or 3 is the second derivative of 1? Maybe. But since we already have 2 to 1, that doesn't make sense. So instead, I would probably go straight to second derivative thought. One at a time. Okay, so let's look at 3 again. So if we were going to identify the derivative of number 3, if we can find the derivative of 3, wouldn't you agree the derivative of 3 would have to be 0 here and somewhere in here? But maybe it doesn't seem to actually have a minimum, it's just a stall point. So this appears to be the derivative. 2 is the derivative of 3. 3, 2, 1. Does that make sense? The whole talk is due Monday. It really is not. It's really not that hard. On number 1, here's everyone listen. So each of the following columns is divided by the graph of F. Underneath F, there are 3 graphs. Label them. Either F prime, F double prime, or capital F is derivative of that. Pick which one's